Okay, our next speaker is Jerry Buxom, our Vice President for Engineering. And like I said, we'll hold our questions to the end of theirs. We're limited to about 10-15 minutes per speaker, although for engineering, we've given Jerry 20 minutes. So he's our prime show pony. We trot him out every now and then, and he gets to come out of the booth and actually talk. So if you'll notice, the Hawaiian shirt from the CubeSat Developers Conference. So
the shirt is an item that they feature at the annual CubeSat Developers Workshop in San Luis Obispo at Cal Poly, so I picked one up this year. They're pretty stylish. Well, I'm Jerry Buxton, Vice President of Engineering. I wanted to talk to you a bit today. All right. Does that make it better?
No, they're dead.
Okay. All right. I'll yell and use the mic. Sorry. So, I wanted to start with a little bit of recap on the Fox satellites. Barry touched on it a bit. We have AO-85 Fox 1 in orbit, and it's got the experiments from Penn State and Vanderbilt. The science and the satellite systems are nominal. Everything is functioning as expected and very well. You probably have heard or read about, but if you haven't, it is a little bit hard of hearing. We had a problem with the transmit antenna, or excuse me, the receive antenna, as we were in the closing phases of finishing the satellite. So the repair to it, we believe, affected the tuning of the antenna. So the idea of an Arrow and a 5-watt HT is possible, but not as easy as we were shooting for in that case. I expect that the rest of the satellites, after what we learned from that, will be much better in that department. The IHU, the onboard computer, it resets every once in a while, and it resets it over the South Atlantic anomaly, which is something that we had also predicted. So that's bringing us some interesting science in that regard. We do know that it was designed to do that because we expected these resets to happen, as a matter of fact, more frequently. So essentially the computer reboots and it picks up where it left off. If you're using the transponder, if you were in South America at the time that it happened, you may not even notice that it had happened. We've got over 2.5 million frames, the last time I looked, of telemetry that have been captured by various hams around the world, and that's providing us with a whole bunch of wonderful data about the satellite, as well as the science for Vanderbilt, our partner on that satellite. And of course, the education is part of AMSAT's outreach, as well as the vehicle, if you will, for getting to the CSLI or the Alana launches that are sponsored by NASA. So the science is an important part of it, not only for what we like to do in sharing, but as well as for getting the launches. Fox 1B is, the CSLI was done by Vanderbilt University ISD for this one. So in other words, they're the PI, the primary on it. Same thing as what we had done with Fox 1A, though. So they've got all 4 of the experiment bays filled up. And the Penn State Erie MEMS gyro experiment, by nature of the fact that it resides on our IHU, flies on actually every satellite. We just held the mission readiness review in front of a panel from TIVAC and Cal Poly and NASA in San Luis Obispo right after the CDW. And everybody gave it a conditional approval because the MRR will typically come out with a few action items, none of which were anything to do with the satellite in specific. In our case, it was more rephrasing of things in the document, the slides for the record, so that there was no question as to what it was stating versus the fact that I could say some things when I was doing it. The delivery and integration into the P-PODs expected around the end of June for a launch that's scheduled no earlier than September 21st, 2017. Fox 1 Cliff was completed a year ago in March of 2016. It's got 4 experiments on it, including our own L-band LV experiment. We'll have an L-band uplink that is switchable or selectable by the ground command stations, AMSAT Ops. Give you an opportunity to uplink on L-band and the downlink back on VHF. This is on the launch that's purchased from Spaceflight Industries. Now, originally the launch that was purchased was for their Sherpa maiden flight, which is a big ring, and there were, I believe, 87 CubeSats that were booked onto that flight. The primary on the Formosat 5, that launch had been pushed back a couple of years, and in fact, that's why the Fox 1C and D are still sitting here at my house. Spaceflight then elected to abort that mission, if you will, to cancel it, and not fly the Sherpa on the Formosat 5. In doing that, in order to satisfy all their customers, including us, they've worked on arrangements to find other launches for us that meet the criteria for what we're looking for. In the case of Fox 1 Cliff, out of what was offered, we elected to go with the Spaceflight's own purchased and owned SSOA launch, which is on a SpaceX Falcon 9 and will launch late this year or early next year. The reason we chose that mission was because, given the mass of the satellites for the orbits that they offered us, that one gave us the longest orbital lifetime for that satellite. Fox 1D also completed in 2016 because C and D were going to fly as a pair on that Sherpa mission. This one has University of Iowa's Herky experiment on it, as well as the others. On this launch, our alternate, if you will, is that it will fly from a PSLV launch from India, and the date of that is being negotiated right now. So I can't say it's going to be the second half of the year, but we haven't locked that down in particular yet. RADIFXSat 2 is Fox 1E. Fox 1E, the Fox project expected 4 satellites. We built the 5th with kind of the leftover parts, if you will, and elected to put a linear transponder on it, so we will fly a 30 kilohertz mode J, which is VHF uplink, UHF downlink transponder. It'll have a 1200 BPSK telemetry and science beacon. And this will be launched on the Virgin Galactic Launcher 1, which is a rocket that is deployed from, I believe it's a 747, but an aircraft in the Mojave Desert. The launch is expected, they say December 2017. I expect that to slip a little bit, being their first flight. Beyond the Foxes, because we have actually kind of drawn to a close with that, we have opportunities to work with some of what we have learned with that. The Fox 1E linear transponder, we're specifically designing to have an interface that would allow us to share it with other projects to fly on their own CubeSat. So University of Washington is someone we've been working with for a couple years, and that's kind of the first run of that. And what we'd expect is that we will be able to build enough Fox 1E LTs to be able to provide to partners so that we can get some more amateur radio in space without having to build the whole satellite. The FM repeater design is of interest to some other organizations. They have been provided some of the plans so that they can look at it and do a little redesign if they need to. Some of the components have gone end of life. So they're looking forward to learning from that and developing their own amateur radio systems for CubeSats. So then at the close of the Fox, what we're looking at is what are we going to do next year or for the next series of satellites. After we finish 1E, when we have a little more time to breathe, we'll be getting together to do brainstorming sessions, as was done with Fox in a sense, to try to figure out what to go with next. The general thoughts in some of our conversations are to go with a 3U. It gives us a lot more flexibility and more power, more room to carry experiments. And we're looking to get higher because, you know, most of the orbits that are offered are roughly 500 kilometer sun synchronous orbits. They last 6 to 8 years depending on when and where they're launched. And of course, we like to go longer than that, right? We also want a bigger footprint, higher up. So pressing for the Golf series, I guess it would be after Fox, greater orbit, larger footprint. There's opportunities if we design for it to go higher than 600 kilometers, even up to 1,200 or 1,400, which would be very nice because that's the kind of coverage you get with FO29 or AO7. And to do that, though, we got to be able to make sure we can bring it back. There's that 25-year rule after end of mission for orbital debris purposes that your satellite has to re-enter. And this is why most of the launches go to the 500 kilometer, because then they will re-enter within the 25 years. The 3U platform also, we expect to use it as a development platform for ourselves for different technologies as we expand that and move to HEO and other orbits. So now looking toward what's going on behind the scenes, I guess, a little bit. Ascent, which was formed a couple of years ago in 2015. They were initially tasked, a group of engineers, to develop the AMSAT communication system for the CubeSat Quest Challenge that NASA sponsored in partnership with Ragnarok. So we've got a satellite that is going to go to lunar orbit, and it's going to carry amateur radio provided by us, and will be able to be available as a transponder later. We also have the AMSAT ground terminal team, which was split off of it from the Ascent to get it out into the public, because that is not a space operation, therefore not subject to the ITAR. And that's designed based on what we came up with the Phase 5 CQC and the need for CubeSats to have smaller antennas as we move to microwaves to be able to provide a station, plans for a station, or even an entirely manufactured station for everyone to use with these future satellites. So Ascent's basically a skunk works, as I said, and the engineers, they're all off playing around in a sandbox, coming up with designs. So whatever they develop helps drive what we can do or want to do for future satellites, as well as the fact as we see what orbits or launch opportunities available, we can work in that sense to develop what is most useful for that. And what makes it fun, what is really cool, is it's going into the stretch of the new stuff, new innovations and things that AMSAT has been known for. I touched on the Phase 5 CQC, so we provide the comms and command link for the 5 and dime scheme, which is the 5 and 10 gigahertz. They are going to orbit the moon, use that to send back some data in order to try to win the prize, and we'll get a cut of that. And then when they're done, the plan is to move it to the Moon Earth L1, and for the rest of the life of it, let us use it as a P5 satellite. Some of the things that Ascent has been producing are 5 and 10 gigahertz LNAs and PAs for the Phase 5, possible future Phase 3 and Phase 4 satellites, 5 and 10 gigahertz patch antenna arrays, a CubeSat format, in other words, about 4-inch square PCB or system design for FPGA software-defined transponder that could fly on a variety of satellites, provide a variety of bands and modes to be able to work, all programmable in the sense of the FPGA, and a CubeSat format safety-tolerant IHU. I mentioned that the Fox satellites reset over the South Atlantic anomaly. As we go higher, especially where there's more radiation, and depending on what our mission is, you may not want to just be able to be so casual about resets and say, well, we'll just restart and pick up. So they've got some ideas for this safety-tolerant IHU, in other words, something that mitigates that. And there's been lots of SDR exploration and other things like the feed horns and what it takes to put together the AMSAT ground terminal. I mean, there's just a lot of information, a lot of new stuff that's coming out of that. For what we do, and Barry mentioned also that we do it, we are you. We are everybody who volunteers to help do this. And we've got opportunities, if you're interested at all, in how to deorbit. As I mentioned, we need to come back down if we're going to go higher. Attitude control, power systems, thermal engineering, mechanical and space frame, RF, and so on. There's a lot of opportunities to get involved and help out with many of these things, with things that you may already know, may be familiar with, and can have fun working with, just as you would at home, in a sense. If you wanted to build a kit or something, build a radio, you can also apply that and help us get more satellites in orbit. So, more volunteers. My drive behind that is, for one thing, we can have steadier progress with the satellites. A volunteer is a very volatile thing. It's very high risk. As a matter of fact, on our CSLI, we list that fact as the #1 risk in getting the satellite delivered, because you don't know what's going to happen to any particular volunteers, illness, family, loss of interest, whatever, or jobs. So the more we have, the more we can spread it out, And that makes it more certain that we can achieve what we want, as well as making it where you don't have to put in as many hours necessarily to achieve something. And it is fun. Even though we're geographically diverse around the United States, when you produce something for a satellite and watch that go into orbit, it's just fun. I don't know how else to put it. So, to sum it up, I'm not going to do questions and answers, and I didn't talk in depth about it, a lot of things, because it's just not doable in a short period of time. But what we have is at the AMSAT booth, we have a number of people and pieces of hardware, and what we're looking for is for you to come by, talk, share, and enjoy it, ask questions. We've got some of the team leaders there and other engineers, and that's what it's all about. That's the best way to find out about it, not for me to get up here and tell you, in a few minutes what I think you might want to know. Do come by. Come by, find out what we got, talk about it. It's ham radio stuff. It's very cool. And get involved. That's all I have. Thank you.